Given an integer x, return true if x is a palindrome and false otherwise. A palindrome is just a word, a phrase, or sequence that reads the same backwards as forwards. Like, for example, madam. You can read madam from right to left and left to right. I'm sure you know this stuff already. So here we have an integer, for example, 121, and this is of course a palindrome. It is not a palindrome minus 121 because this is not a number, doesn't make any sense. And 10 of course is not a palindrome because you have 0, 1. The constraints are that the number can be in the range int min, int max. Here is prompting me, could you solve it without converting the integer to a string? Well, I was actually thinking about that. Indeed, the naive solution can be converted into a string and then making a string compare, but it is not actually necessary. You can do directly with numbers. And in my opinion, it's frankly easier. So let's start from the beginning. So we have when the value is equal to 0, for example, this is a palindrome. So you're going to simply return true. Then we just saw that all the negatives are not a palindrome. So if x is minor than 0, you return false. And here we can also add all the numbers that have a 0 at the very end. Like for example, the number 10 cannot be a palindrome, so I say or x mod 10, which is actually the base, so we are gonna use a define. We shall avoid magic numbers, so define base 10. So here say x mod base is equal to 0, right? So I can simply use the bank just before, not x mod base. Basically, I'm taking this last figure of the number itself and telling, hey, if this is 0, I'm sure this is not a palindrome because it doesn't make sense, right, to have 0 in front like that. It's pointless. No natural number has a 0 on the forefront. Okay, so given these conditions, you simply return. Now we have the actual meat, the actual algorithm, and let's ponder with some pseudocode what I'm thinking about. So let's assume x is equal to 1221, which is of course a palindrome, right? I would like to have a loop that is talking inside a variable that I call reverse every time the last figure of the number. So 1 initially, then 2, and so on. So initially reverse is going to be 1, and then x I'm going to divide by 10. So x is going to be 122. Then reverse is going to be 1, 2, x is going to be 1, 2, then reverse is going to be 1, 2, 2, x is going to be 1, then reverse is going to be 1, 2, 2, 1, x is going to be 0, right? Something like that. As you can see, I get reverse that contains the actual same value as x, which now is 0 because I performed division by base, right? So as you can see here at this level, I get already the response, right? I already see that these are true palindromes. I don't need to go any further. Basically, I have to say the loop has to go on until reverse is minor, right? Until reverse is minor than x. That's my condition. So when we are at this level of the loop, I want to stop. So these operations are not gonna be performed. All right, let's write some code so you can understand better what I'm saying. So let's create my variable, which is an integer that I call rev for reversed, and we're gonna initialize with 0. Always remember to initialize, otherwise there's gonna be garbage value. Then I do my loop. So while reverse is minor than x, right? So rev minor than x. What do? So every time you have to take the last digit of the actual x, right? So basically we have a pop. We can say, to be pedantic, int pop, and pop is equal to very easily x mod base, right? Then very simply I have to say reverse is equal to what? Well, every time I have to add pop, right? So it can be plus equal pop, but this is not correct, right? Every time I have to increase the order of magnitude of the actual reverse, so I need a shift operation. So I do reverse is equal to reverse per base, right? Every time I'm gonna shift the actual figure plus pop, like that. So this is a shift. And that's it. Basically, this is a loop that is recreating this condition. So we are gonna reach this level given this number. At the very bottom, we have just to return reverse is equal to x. Now, this is the algorithm, which is not totally correct. For example, when we have an odd number of figures in the number, this is not going to work. Nonetheless, let's launch the code and let's see what is going on. So I'm going to compile and launch. As you can see, 0, 9 works, 10 works, negative works. Here I have an odd number of figures, and as you can see, it doesn't work. Expected is true, but I got false. For even figures as well, I got a mistake. 1, 2, 2, 1. There must be something wrong with the algorithm. First here, I forgot to make x divided equal base, right? Every time I have to divide the value. Okay, let's retry. And now for even figures, it works. Expected true, but with odd figures, it doesn't work. Let's fix this problem. So let's pretend this time we have this number 1, 2, 5, 2, 1, which is a palindrome. So reverse initially is 1, and here we have 1, 2, 5, 2. Okay, here 1, 2, 5. At the third time, here we get 1, 2, 5, and 1, 2. Now reverse is bigger than x, right? So we have to stop. This is the condition where we stop. But you see, this time we have 125 and 12. This is a palindrome, right? Because we understand this 5 isn't influential. I only care about this 1, 2 and 1, 2. So here at the very bottom, at return, I can simply say if reverse is equal to x or reverse divided by base, right, is equal to x. Like that. Basically, I am removing this with this divided by 10. So of course I will get 12 is equal to 12. Let's try now to launch this code. So compile, launch. And as you can see, this time works. So 12, 3, 21, true and true. Now, if you want to increase a little bit this code, we can probably get rid of this variable. So we can save a little bit of memory. So I'm just going to delete this and I'm just going to write directly x mod base like that. All right, this in my opinion is the solution. I'm gonna paste here. Okay, I get a runtime faster than 93%, which is pretty good. Memory usage 6.8 megabytes, which is very bad. Indeed, we can do much better, I guess, memory-wise, but I really care about runtime. Well, I guess I need your suggestions for memory usage. So leave a comment, my friend. We're doing this together.